Alrighty, happy Monday. I hope you all are getting outside and getting your vitamin D with sunscreen. Yes? Some of you, I can tell from your color. Alright, so today we are going to be working on I can simplify and multiply radicals. Maybe in the opposite order. I can multiply and simplify radicals. So, have you had a chance to do the warm-up yet? Give me a thumbs up if you've done the warm-up. One thumb. Any other thumbs? Okay, take a moment, please, and simplify 5 squared times 5 to the power of 8, and then find the square root of 144. So take a moment to do that. And if you have done that, go ahead and write down everything that you know about radicals. And if you don't know anything, you can say that. I don't know what a radical is. So this is coming from Module 4. So some of you may be there, some of you may not be. Take off your backpack, stay a while. I'm not going to take it, I promise. Okay. So when we are looking at this first problem here, what do you notice about 5 squared times 5 to the 8th? What do you notice about that particular problem? You've got to notice something. It can be really basic. I know you noticed something.
They both have exponents?
They both have exponents. Awesome. So that's good. So we have exponents. What else do you notice? Andrea, what do you notice about this problem? It can be something, don't look too deep into it. So it has exponents. What else do exponents have? What's that other word? Colton?
Coefficients.
No. They actually don't have a coefficient. Oh, good guess though. So coefficients are tied to a variable. So this is your coefficient. Okay, for almost all of you were here last week. This is almost as basic. It is as basic as starting with Katie's square. Remember that last week? When we were talking about drawing those shapes? And Katie correctly told us, draw a square, draw a box. What else do you notice about this problem? Eden.
There's 2 5.
There's 2 5s. See, I told you it was basic. What do we call those 2 5s? Besides 5. When we're working with exponents, what do we call it? Annie, do you remember?
The coefficient?
No?
Or the constant?
No? Base. Yes, these are the bases. So when you have bases, and this really is important to recognize, when the base is the same, how do you pull that together? When the base is the same, how do you pull that together? Say it.
Since the bases are the same, can't you do the top now since they're the same?
What do you mean do the top?
You can multiply the exponents, right?
Close. Very close. So we take that base and we add them together. Oops. that becomes 5 to the power of 10. 5 to the power of 10. If we were to completely solve this, not simplify, but solve, what is 5 to the power of 10? Use your calculators. You may use your calculators. To the power of 10. Louder.
A lot of numbers.
Okay. Read them out.
Just the numbers individually?
Yes.
I can do that. 9, 7, 6, 5, 6, 2, 5.
All right. So I'm going to add some commas. How do we say this in math language? What spot is this number in? The millionth. So this is 9 million.
765,000.
765,000.
625.
625. Nice. Okay, now, last one on our warm-up. What is the square root of 144? Eat it.
12.
12. How did you get that?
12 times 12.
So you recognized that when we have the radical sign, radical, we're trying to find the base number times itself. So we take the square root, and in this case, it is 12. And did you use your calculator? No, you knew it. Awesome. Using your calculator is okay. Alrighty. So, nice job, nice job. So we're going to be taking these things called radicals. And I know I say I like so many concepts in math, but this is literally one of my favorites. That's why I'm a math teacher, you know. So when we have adding radicals together, well, let me ask you, if I had something like this, 2a plus 4a, can you simplify this problem, 2a plus 4a? How would you do that, Colton?
Add like terms.
You combine like terms, and when it's simplified, it is
6a.
6a. So we have 2a's here, 4a's here, combined together, we have 6a's. Now, when we're working with radicals and we're adding or subtracting, we treat them the same way, as if we're looking for the like term. So what is the like term in this particular problem? Square root of 3. It's this right here. So I have 2 times the square root of 3 plus 4 times the square root of 3. I want to simplify this, and I end up with, oh my goodness, not 2. But what's 2 plus 4? 6 square root 3. You treat what is under the radical, you start looking for like terms, things that are the same. Things that are the same. What if we have something that looks like this. 4 radical 7 plus radical 7. If you were to simplify that, combining like terms, Eden.
Wouldn't it be 5, 7? Because there's an invisible 1.
Yes, nice, nice. There is an invisible 1. Because remember, as mathematicians, we like to be efficient. So without that 1 written there, how many of these do you see, Katie?
1.
1. That is why we don't have to write it, because you can recognize that there is just a single 1 there. So we add the numbers that are in front, 5 radical 7. How about a subtraction problem? Because that does happen. Alrighty, so if I have a number, I don't know. Andrea, give me a number.
4.
4? Beatrice, give me a radical. 8. Okay. Minus 6 radical 8 plus 2 radical 5. All right, I have 4 radical 8 minus 6 radical 8 plus 2 radical 5. Simplify this problem. I went all crazy. I put negative numbers in there. Alrighty, Beatrice. What do you have? Nothing yet? So if we were to talk it out together. -2. Nice. -2 what? 8, yes, yes. This stays the same. So 4 minus 6, that is where the -2 comes from. Radical 8. And Colton, what would you do with this? 2 radical 5.
Where you just keep it the same
You keep it the same. Why?
because there's no other like terms.
There are no other like terms. So this is as much as we can squish it together. We don't always come up with a nice, easy whole number. Sometimes this is as far as we can go. Sometimes we can go a little farther. And this, I think, is the fun part. Can we factor any of the numbers that are under the radical? Can we factor them beyond 5 times 1 or 8 times 1? Can you factor 5 anymore? Or is it prime? Is it prime, Katie?
Yeah.
Yes, it is prime. Is 8 prime?
Yeah.
No. because what numbers can you use to multiply to get
4 and
8?
2.
So you have 1 and 8, and you have 2 and 4. Okay. Now keep in mind, these are all underneath the radical sign. Are either of those numbers a perfect square? Which means a number that can be multiplied by itself. Similar to what you did, Eden, with the 144.
2 times 2
Yes, yes. So Eden's recognizing that the number 4 here, I'm so glad we have all these colors, that this is a perfect square. 2 times 2 equals 4. That means that we can simplify this. We know that the square root of 4 is 2, so I'm going to take that 2 to the outside of the radical, and that leaves 2. Now I haven't brought this down yet, so I'm going to bring it down now. Actually, let me use my green pen so you can see it. This is where I think I like this part. So we still have minus 2. We still have minus 2. When we have a perfect square and we bring that perfect square on the outside, we are going to multiply it by the coefficient that is still here. This is an example of a coefficient. So what's negative 2 times 2? Negative 4, square root 2, plus 2, square root 5. We bring this puppy down. And this is our final answer. So let's identify some steps so that when we do some other practice problems, we have some steps that we can work with. So what is the first thing we did? What is the very first thing that we looked for?
Like terms.
Like terms. So I would say something like find like terms. Okay? Then what did we do? What did we do with them? We found them. What did we do? We combined. So we'll combine like terms. Okay. Then what did we do? So right here, this is where we did number 2. This is number 1. Yeah. So we factor and find perfect squares. Okay? So that's this part. How would you describe this? Yes. So if a perfect square, I'm just going to write PS for perfect square, multiply with outside coefficient. Or we could say outside number. Okay, that's this. And finally, 5. How would you describe that, Katie?
I'm not sure.
Okay, fair enough. Let's help her out. How would we describe this last part? Maybe add it all together. Add or subtract it all together. Bring it all back together. Hello, sign in, please. Add or subtract. Which is another way of saying simplify. And you're done. Voila. All right, let's do another problem. How about 2 radical 9 plus 3 radical 9?
Add 2 and 3.
Okay. Katie, what's the square root of 9? What number times itself equals 9? 3. Good. So we can simplify the 9 to 3. Because that cancels out the 9, right? We bring it out, multiply. What's 5 times 3? 15. Bada bing, bada boom. Simplified, multiplied, done. I think this is too easy for you guys. What about when you're multiplying together? So if we're taking a number like 2 radical 3 times 5 radical 3.
2 times 5.
What did I hear?
2 times 5.
Okay, so what's 2 times 5? All right, Andrea, what's 2 times 5?
Oh, 2 times
2 times 5.
10.
10. Good. All right, so we multiplied what's on the outside here together. 10. What do we do with this?
Will it just go under
It doesn't.
Is it 3 times 3?
It is 3 times 3. So 3 times 3 is 9. So note that when we are multiplying radicals, we multiply what's on the outside. Hey, Christian, would you sign in, please?
Oh, yeah.
What's on the outside, and we multiply what's on the inside. And by inside, I mean inside the radicals. Are we done? Are we done? 10 radical 9. Are we done? What do you think, Colton? Why not?
Because you factor 9.
You need to factor 9. So from our previous problem, we know that square root of 9 is 3, which means, Katie, when I pull that 3 out, what am I going to do? What did we do with it before? So we pulled it on the outside here. Yes, yeah. We're going to multiply it. We're going to multiply it by the number that's on the outside here. 10 times 3 is 30. Yay. Okay. Let's do another one. Let's do. Have you guys written this down?
What?
The problem. So you have something to refer back to. Just saying, might be helpful. So why don't you do that while I write out another problem.
Can I use this?
Yes. So once you have written this down, please work this problem. Hi, Sophia. Go ahead and sign in. 2 radical 3 times 4 radical 12. Go ahead and write this down. Write it down, simplify, and solve. And if you get that done quickly, you can go ahead and start on this other problem. Right. Yeah.
The second one.
Mm-hmm.
Like with the plus, because I was I just
So you understand the adding part?
no, the multiplication, I don't know. Adding is basically just the same, but you just don't multiply the. So it's just 7. This, yeah, that's 2 times 2 7, and you just keep this.
Right, does anybody need more time on this problem? Raise your hand if you need more time on it. Okay, so keep going. So Grace, have you done this one?
So pay attention to what's happening between this guy and inside the parentheses. What math operation's happening there? So a parenthesis is not an operation, that's organizing.
Well, addition.
What's happening between this guy and that? Where's that side?
How does that even work?
What is, that's 6? So what number is that? Yes, yes. Okay, don't be shy about asking for help, either from me or from some of your classmates.
Not totally.
You're getting there.
Think about distribution when you're distributing.
Yes. Okay, so multiply the outside by the outside, inside by the inside. So Andrea, to get started, tell me how you would start a problem like this.
Multiply 2 and 4.
Why 2 and 4?
Because they're on the outside.
Yes, you're going to multiply what is on the outside of the radical. Nice. So that's step number 1. And then what do you do, Andrea? Take us through to the next part.
Multiply 3 and 12.
Yes. Very nice. You're going to multiply 3 times 12, which is 36. Okay, that's a beautiful thing. Make sure you're not confusing multiplying with adding. Always, always pay attention to what's happening in between. Now, is 36 a perfect square, Grace?
Yeah.
Yes. So that means we can factor it easily to 6. So we pull it on the outside. We multiply them together. 8 times 6, Colton?
48.
48. So our mantra is going to be, how do you get started? How do you get started? All right, any questions about this problem? That's the trick with math, right? Knowing how to get started. So here we have 2 times the square root of 3, in parentheses, 5 plus the square root of 3. What's happening here? What are they doing together? Are these being added? Are they being multiplied? They're being multiplied. And where is that multiplication happening?
The outside to the inside.
Outside to the inside. Very specifically where?
2 to 5. 2 to...
Right here.
Yeah.
Okay, so we're going to multiply all of this by the first term in the parentheses. Then we're going to take that again and multiply it by the second term that's in the parentheses. This is another way of distribution. A lot of times when we see distribution, it looks something like this. That might be a more familiar pattern that you're used to seeing instead of the radical symbol. All right, so if we're going to multiply, let's do the first one first. That makes sense, right? First one first. 2 radical 3 times 5. What is 2 radical 3? 10 what? radical 3. 10 radical 3. So we multiply the 2 and the 5 together, and since there's no radical by the 5, we leave the 3 alone. How about this second term? So what coefficient do we have here? We have a 1. So 2 times 1 is 2. We're going to multiply what's under the radical together. 3 times 3 is 9. Okay. Are we done? No, we're not done. We're not done because we can still simplify the 9. It's not prime. So we're always looking for prime numbers under the radical. That tells us that we're done. What is the square root of 9? 3. I'm going to pull that out. I brought everything else down. So 10 radical 3 plus 6. 10 radical 3 plus 6. Any questions about these steps? Very quiet. Okay. We're going to do one more practice problem like that because I want you guys to have that solid. And then I have a little worksheet for you. How about, do you have this down? Is this written? Can I erase it? I'll take that as a yes. All right. How about radical 6 times radical 2 plus radical 3? Radical 6 times radical 2 times radical 3. That was a yoga breath. Did you know that? But you didn't know that. So how do you get started? Yes. So how do you get started? Yes. Yes. Good. So what's the next step? You're not like two, so you can't add them. So you need to factor. You need to simplify the radicals. So do you remember what factoring is? So go ahead and factor 12. Anything other than 1 times 12, because that won't get you anywhere. Like 12. It's not a perfect square. So that means you need to factor it. Find some two numbers that multiplied together equal 12. Okay.
Let's go ahead and write down 6 and 2. Like that. No. 6 times 2. Yes. Okay, so well that factor, the 6 factor, 4. Make it smaller. Okay. How are you doing, Missy?
This side is perfect square.
That is not a perfect square.
So I have to do the same.
Uh-huh.
on this side.
Uh-huh.
Okay, go ahead and factor the 18.
So I'm seeing you guys are making great progress. So square root of 6 times 2 is the square root of 12 plus the square root of 18. Now I'm seeing some factoring going on. 2 times 6 and 2 times 3. So I'm just going to look at this part right here. And these are still completely under the square root symbol. Are there any perfect squares here? There might be. They might be hidden. Because what if you multiplied 2 and 2 together? Would that be a perfect square? Oh, yeah. Yeah. Anytime you are under the radical and you've got two numbers that are the same, that's a perfect square. You can cancel them out and bring it on the outside of the radical. And what is left is a 3. If you had chosen 4 times 3, you might have recognized that that was a perfect square a little faster. Both methods work. Both methods work. That's the beauty of math. Okay? But we're not done. So, what are some factors of 18? What did you choose? 6 and 3. We know that factors of 6 are 2 and 3. We have 2 3s. They make a perfect square. So we can pull out the 3 on the outside of the radical, leave the 2 there. And these just happen to be the opposite of each other. That's just the way the math worked this time. Can you do anything else? Nope, it's done. That is as simplified as we can get. So if we, with 18, something that may help if you can think of a factor that is a perfect square like 9, sometimes that can help you speed along the process. But both methods are okay. When you find 2 factors that are the same number, you just cross them out, bring them on the outside of the radical. Questions? We deal with radicals a lot in your future. Okay, so what I would like you guys to do, I'm not going to have you do all of these. grab one. And Katie, did you get one?
I have one.
Oh, you have one. Okay, thanks. All right, what I would like you guys to do is the even numbers. That's what I'd like you to do, the even numbers. Alrighty, so complete the even numbers. 2 through 24 even only. Alrighty? And I would like to be able to go over these answers before you leave. And I think you'll be able to get them done in time. Questions? No? Don't be shy. Ask me. Get to know your neighbor.
I know my neighbor pretty well. He lives in my house.
What was that?
I know my neighbors pretty well. They live near my house.
Well, good.
No, my real neighbors.
But doesn't the definition of neighbor mean those around you?
Yeah,
So right now you have neighbors around you.
but I'm not in my house, so they're not really neighbors.
Aw. Aw.
Just saying.
Just saying. So there's about a month left in school, which means if you're behind, you need to get caught up. If you need to fix things, you need to get them fixed so that you are passing this class. Yes, ma'am.
Do we have to do the work sample this semester? Because I don't think we did that last.
I would love it. Yeah, the snow days really messed us up for that. So, Annie, let's see, it doesn't apply to Colton. But Annie, yes, I would like for you to do the work sample.
Is that, do I have to come in and do that, or is it like in the
That is an in-person proctored. So it's not something that we could do if I'm talking.
Right.
But it's to your advantage to get it done.
Okay.
Yeah.
Is it like, is it about what we're learning right now, or what I'm learning
Yes.
right now? Oh,
Yes,
okay.
so it's about Module 6.
Oh, good.
Yes. Yes. Okay. And I think Kylie, I think I'll want you to take one. It's part of your high school requirements, so it's nice if you've got a real grasp of the concepts that you get it done. Yeah, and it doesn't matter if you stay with MIWA or if you transfer to another school. It's part of your permanent record, and it goes towards your diploma requirements. So it's a good thing to get done.